Hello everyone and welcome to today's video where we will go through some of the latest questions from the topic of GNAV. So we have prepared 6 questions. All of them have been seen in the actual exams in the last 30 days. I'll try to give you some tips and show some supporting graphics. So without any further ado, let's jump into the questions themselves. What is the rate of descent for the final approach segment of the destination airport considering the following data? So remember that when it comes to the rate of descent questions, the key rule here is that for the most part, the rate of descent is calculating using some rule of thumbs. The most popular and widely known one is your ground speed times 5. And this is absolutely true. Your ground speed times 5 will give you your rate of descent. However, it gives you your rate of descent for the standard glide path angle of 3 degrees. The situation is a little bit different when the glide path is non-standard, so either higher than 3 degrees or lower than 3 degrees. For us to understand how to calculate it, it's best to understand pretty well how this 5 times ground speed rule is calculated. The full formula for your rate of descent is your ground speed times 5 times your glide path divided by 3. So of course, when your glide path is 3 degrees divided by 3 is 1, this is why the 5 stays on its own. However, in this case, if the glide path is 5.5, the full formula will be your ground speed times 5 times 5.5 divided by 3. As you can see, in this case, this increases the multiplication factor to higher than 5, and in this particular case, it will give you, with the ground speed of 110 knots, 1008 feet per minute. Of course, if this was a standard 3 degrees glide path, so the standard one that we are used to for example, ILS approach, in that case, we would have 550 feet per minute of rate of descent to maintain this glide path with this given ground speed. And now for question number 2. So which of the following alternatives is correct when you cross the international date line? So international date line is of course something that has been agreed by the countries. It is an artificial line, and it comes from the idea of countries wanting to maintain certain time zones for the simplification of the politics and simply people's life. We have different times that you need to know for your navigation exams. These will, of course, be the local mean time, which is the sun time. This differs by 1 hour is 15 degrees on the globe. We also have the UTC and GMT. The Universal Standard Time is an atomic clock time, and the GMT is based on the Greenwich Meridian. However, they will be, in most cases, exactly the same. However, the way that they are calculated is slightly different by theory. And then, of course, we have these standard times or the local times that are used by the countries and created by the countries. So we have the globe divided into different time zones. The last time zone that you have is called the international dateline, and the international dateline essentially is the point at which we have a new day and an old day. The international dateline follows the exact same principles as all the local, all the time zones, meaning if we begin in Europe at the Greenwich Meridian, if we go to the left or if we go to the western side, then the time decreases, and if we go to the eastern side, then the time decreases. And this is also why the Australia or the countries most east of the Greenwich Meridian will enter the New Year's first. So with this in mind, the date that will increase if you're crossing on the westerly heading will be your international date line. And here also I just wanted to show you, this is what the international date line looks in the globe. So as you can see, it is absolutely artificial. You can see that, for example, the Russia, of course, maintains the same day overall, and this only crosses when it comes to the US in the north. And then we have this hammer-shaped line. This is where the town or the country of Kiribati is. So this is just as a fun fact for you. Kiribati is the first country to enter New Year's every year, and this is their beautiful flag. However, this is just a fun fact, not something that you need to know for the exams. For question number 3, given the following information, what rate of climb is required to climb to flight level 80? We have the distance of 25 nautical miles, QNH, transition altitude, mean ground speed, and we assume 30 feet per 1 hectopascal for the lapse rate. And now for these questions, there are quite a few rules of thumb that you need to remember. The one and the best advice I can give you is to always draw it on a piece of paper. It makes it much, much easier, no matter how simple or straightforward you believe the question to be. I have created such a uh, such a such an illustration to show you how more or less it looks like. First of all, always remember to use the common units. So if you have flight levels or altitudes, always make sure that you change them into altitudes so that you always subtract, multiply, or use the same units, the same as you would in maths when it comes to liters and kilograms or grams and tons. Always make sure you use common units, in this case, altitudes to altitudes and flight levels to flight levels. Lastly, remember that your transition altitude is simply a place at which we change our altimeter reference, because when we are close to the ground, we want to know the altitude in order to have the obstacle clearance and avoid the terrain. However, higher up, our main concern is not the terrain, but traffic avoidance. So we need a common datum for all aircraft around a certain airspaces, and this will be our standard pressure setting. So as I mentioned before, you can see the SPS is higher than the QNH. I have transformed the flight level 80 to altitude of 8,900 feet. And then all you need to do is to subtract your aerodrome elevation if there is one. Now, how much time it takes to cover 25 nautical miles in with the ground speed given? Of course, this will be an easy calculation. This gives us 9.4 minutes. Then the next thing you need to do is simply divide your altitude, taking into account the elevation if it's given in the question, and then you have your feet per minute of climb or descent. Remember that for some questions, you will not be given a mean ground speed, you will be just given winds. Remember that for these questions, you always take wind during your climb, that is at 2/3 of the climb, and for descent, you take the winds at half of your descent. This is because when you descend, it's easy to keep constant descent rate because you are not really using an engine, especially if you're doing an idle descent. However, when it comes to climb, your engines will lose its power, especially if we're talking about these smaller engines, the higher you go. However, it's true for most aircraft. The higher you go, the less dense the air, the less powerful the engines, so that your climb is slightly slower at the last third of the climb. This is why we take winds at 2/3, as you spend more time over there. For question number 4, 5 hours, 20 minutes, and 20 seconds corresponds to a longitude difference of. Again, as I mentioned before, this is a very, very straightforward question. You can solve it in many different ways. If you have a calculator with the DMS button, you can simply put it in there and you'll get the correct answer straight away. The way I always did it, and I recommend you do it as well, just for the simplicity, is to remember that 15 degrees corresponds to 1 hour. So of course, if you have 5 hours, 20 minutes, 20 seconds, this simply means that we have just over 80 degrees of longitude difference, because 5 times 15 is 75, times one third of 15 is again 5 and a little bit, which is 20 seconds. You can also, which is exactly the same thing, use the 1 to 4, which is 1 minute corresponds to 4 degrees. Now for question number 5, given the compass heading, true track, drift angle, and deviation, what is the variation over there? This is again a very straightforward question. I'm sure you'll see at least a couple of those in GNAV, potentially even flight planning. Now the question is, how do you solve these questions? There is a very easy mnemonic that you should follow and that I highly recommend you remember, which is the Cadbury Dairy Milk, very tasty, and then driving trucks. Now, how you solve it during the actual exams? I recommend that you create a small table and you simply put all the known values at the top of the table, and all the unknown values you calculate below it. And I have an example to show you exactly what I mean here. And of course, as you go from left to right, you add the values unless there is a minus, and from left and from right to left, you subtract these values. So from the compass heading of 233, we have a negative deviation of 3. So 233 plus minus 5 and 3, which is magnetic heading of 230. Then we have from right to left our true track 256, our drift of 10. Again, from right to left we subtract, and from left to right we add. So in this case, our true heading will be 246. So now we have the two values of magnetic heading and true heading. All we need to know is figure out the variation. And of course here we see that the variation needs to be 16 in order 230 plus 16 is 246. The way to remember whether it is west or east, you can remember it with a mnemonic magnetic, the variation east, magnetic least, variation west, magnetic best, meaning higher. So of course, in this case, we only have one answer, which is east. However, you can see that variation east, magnetic least, and as you can see here, my variation east, the magnetic is less least than the true. And now for question number 6, so the last question that we have here for today. Given the following information, at what approximate distance from threshold can you expect to capture the glide path? Aircraft height 2,500 feet and ILS glide path angle of 3 degrees, which is our standard. This is a great question and a very practical one at that as well. You see that it has a lot of questions and a lot of comments, sorry here. However, it is an extremely simple question and you'll see why in just a second. The one thing that you need to remember once you start flying, especially the big airline jets and the heavy aircraft, is that the most difficult thing is calculating your rate of descent in order to have the most fuel efficient idle descent at the 3-degree descent angle. How you do that? There is a very simple rule of thumb, which is simply to multiply the distance to the threshold or to the airport by 3, and this is your altitude that you should have. So for example, if your DME is showing 100 miles from the airport, you multiply it by 3, you have 300, so it means that you should be starting your descent from flight level 300, and you should be at flight level 300 at 100 DME. If you are 50 DME from the station times 3, you should be at flight level 150. This more or less ensures that you have this constant 3-degree descent rate. So for this question, the same thing applies. If you are going to maintain your glide path angle of 3 degrees, you want to have your distance to the station multiplied by 3, and this gives you your altitude. In this case, you can see that the first answer here, 8.2 times 3, this is 24.6, meaning your altitude at this distance should be 2,460 feet. And as you can see, this is the closest to your aircraft's height given in the question. And this will also be the correct answer here, rather than the other ones. So this is, again, a very simple rule of thumb that I highly recommend you use for the exams and also for your future flying. You simply multiply the distance by 3, and this gives you your altitude. You can also use this to figure out whether you are too high or too low as compared to your 3-degree profile. And this will be everything for today. So thank you all for joining me today. I hope to see you in the next video. If you have any questions, as always, feel free to ask in the comments below. All the questions, of course, are available on the Airhead website. So I highly recommend that you set up an account if you don't have one already. I wish you all the best for the exams, and I hope to see you in the next one. Bye-bye.